Okay, so you guys have your comp books opened up to the calorimetry lab that we started last week. If you don't have it, or last week, I think it was like 2 days ago. It feels like a year ago. Yeah. Yeah, by the way, welcome back, seniors. Yesterday it was like empty in here with all of you gone, and quiet and peaceful and so nothing. It was just so sad. We're going to miss all of the students. The lab that you're going to be working on, it's going to be a team effort. There are two things that you're going to be doing. The first thing you're going to be doing is finding the specific heat of aluminum. Would you look on page 237 in your textbook? Would you mind grabbing the desk and hauling it over here? Okay, on page 237. Would you please look on page 237 and find the specific heat of aluminum? Okay. So the point of the first part of the lab is not that you need to find the specific heat of aluminum because you don't know it. The point is you need to find the specific heat of aluminum because you need to see how good your calorimeter is. You should get 0.91. You probably won't because that's how science works, especially with us in here. So if you're not going to get 0.91, you have to see how close you are. So when you have your unknown sample, you're going to do exactly the same procedure for your unknown sample. You'll be able to tell like what range off it is. So if you get 0.7 instead of 0.9, you know what percent off you are. Then your other unknown can be within that range of numbers also. Okay. So all we're doing is calibrating the calorimeter with aluminum. So taking a look at the equation that we're starting out with. Well, first thing I need you to do, take your hand, put it on your table. What's happening to the cue of your hand?
The heat is going from your hand to the table.
Yeah, the heat's going from your hand to the table. So is it positive or negative?
Positive. No, negative.
Negative. Okay. So if the heat of your hand is negative, what is the heat of your table?
Positive.
And what is the amount?
A number.
Yeah, the cue. But it's, say that letter. Okay, it's going to be the same both ways. So if the heat of your hand is giving away 300 kilojoules, so it's giving away, by the way, you'd kind of have to be on fire for that. But if it's 300 kilojoules, then the heat that is being taken in by the table would be the opposite sign, but also 300 kilojoules. So it's the same number with the opposite sign. I'm going to keep saying flip the number. All I mean when I say flip the number is do the opposite sign. Okay? So we're going to start out talking about water. What is the Q? Well, excuse me, you're going to solve for the Q of water. How can you find M of water? On your paper, right? What material you would use to find M of water? On your paper. You can talk to your lab group, but don't tell me. Okay. How can you find the mass of water? Okay. Some of you are getting really clever.
Graduated cylinder.
Definitely. Okay, so when you have the M down, how can you find the C of water? Trick question.
You know it.
Yeah, you've already got it memorized. Delta T, how can you find it? What material for that? Okay, so your materials list. You should have those simple things. But what is the other thing?
A scale.
What is the other thing you're going to need to do this part of the lab?
A scale.
Okay, you will need a scale, but you're going to need to say that louder. You need a calorimeter. How many of you know what a calorimeter looks like? Just one. Okay, so for the rest of you, you are using exactly the same calorimeter that I used when I did this lab for the first time, which was in college, by the way. When I did this lab for the first time, they told me calorimeter, and they kept talking about how we need a calorimeter, and I had no idea what they were talking about. And so we get into the lab. And they drag out the calorimeters, and it was the most disappointing moment of my life. This is not a calorimeter. This is. Okay. It is actually really brilliant because if you can do science for cheap, you can do more science, right? So you have a styrofoam cup. It's insulating water. Okay? You need 2 of them because one of them, your hand temperature can actually change the water just a little bit. You'll heat it up a little. So you put 2 of them in. And then your water is inside here. And you can take its temperature through the hole in the top. I do have to warn you 2 things. This glass thermometer is made of glass. It is also very pointy. So things that people have done, they've broken the thermometer because eventually you end up putting your metal into the calorimeter. They stab it in there and try to stab through the aluminum. Doesn't work. Okay? And then you're working really hard at it, so you stab all the way through the styrofoam cup. That also does not help you. All right? So be careful with your thermometers. So this is the easy part. You can figure this all out for water. You get a mass of water. You put it in your calorimeter. All we're going to be using is water out of the sink. You take the temperature of the thing, and you're good for the water. If we were trying to find the temperature of water, this would be perfect. But now you have to figure out, and I want you to stop and think inside your head for a minute without saying words out loud, and then talk quietly with your lab group about how you can get metal to a temperature that you know. Can you take can you take the temperature of a piece of metal with a thermometer? So how can you get the metal to a temperature that you know without breaking the thermometer so that you can take a piece of metal and shove it in here and have it change the temperature of the water? Okay, talk about that for a minute.
Water or temperature, you know, so then when it changes, you put acid. No, that doesn't make sense.
Where's your chair?
I mean,
Say you just said again.
Take it away. We don't know what we're talking about. Take it away.
Well, you're not. Did I say you all obviously know what you're talking about?
I think that melting point would definitely be something to factor to go. Yeah, I mean, like, what else could we do?
And doesn't it have a low melting point too, so it's possible to get to with like a...
Oh, yeah. Aluminum?
Yeah. Yeah?
Oh, yeah,
metal.
obviously aluminum.
Yeah?
Yes, David.
For a metal though.
We're trying to find an unspecified metal. No, we're doing aluminum first. Aluminum first, and then...
Oh, yeah, you're right. Okay, can I have your attention back up here? All right, so how many of you have an idea for what you can do to get the metal hot? Okay. You can probably think of a lot of ideas for how to get the metal hot. How many of you thought of a Bunsen burner? How many of you thought of a hot plate? How many of you thought about glaring at it fiercely until it, yeah. I've tried. It only works on people. Okay, so here's the thing. You need to get the metal to a temperature that you can predict. But all you have available to use is water. Okay. What can you do to water to get it to a temperature you can predict? You can boil it. What would its temperature be? 100 Celsius. Thank you for saying Celsius answers. Okay. And then what would it be what's the other temperature you know for water? Freeze. Okay. Which would you prefer to do?
Heat it up.
Why do you want to boil it instead of freezing it? Yeah. Because we have the materials for boiling, and also because have you ever stood and watched water freeze? No. Right. I'm crazy patient, right? You know that. And I've never done that either. It takes too long. So if you get the water boiling, what can you do with the metal? Put it in the water, and then what will it be? Okay. Is that your final or starting temperature for the metal? Starting. Okay. So I'm just going to say that you need it in the water for a little while in order to get it up to 100 degrees. You can't just dip it in because then the surface is 100 but not the center. So I'm going to say that you probably want it in the water for about 3 minutes. Okay? Now, would you work with your group and start from the very beginning and write procedures for this lab?
So are we going to need tongs then?
Very good. You're probably going to want to... No. You're never going to put boiling water into the styrofoam. You put cold water in the styrofoam. The boiling water is in a beaker.
Melt the cup.
Right. That's what she was asking. Okay, so you're going to have to add to your materials list as you're going.
So first,
No.
Just do it. You guys are
Wait, do we take the mass of the water first, or do we take the? We have to take the temperature. So I believe that step one should be that we take the temperature of the water in the calorimeter, and then we use.
So what do you guys have for the first thing you're going to do?
Gather the materials.
And the second thing?
Take the temp of the water with the calorimeter, right?
So maybe you should put water in the calorimeter and then take.
Well, yeah.
Yeah. Okay.
We're
So just go through the steps.
Yeah. How much water do we use?
Okay. So somebody just asked me a really good question. How much water are you using? So I'm going to show you your aluminum. A couple things you need to know about it. First of all, this is scavenged aluminum. We got this aluminum from, I think it was some sort of a physics experiment thing. So it has a hole in the bottom. Okay? You need to make sure that you have in your calorimeter enough water to cover the aluminum, but you want it tilted to the side because the less water you can use, the more accurate your results will be. Okay? So you just need enough water in the calorimeter to cover the aluminum. So people are looking for a precise number, and the answer is enough. You have to make sure it's enough to cover the aluminum and not more than that. When you put it in the water, when you put this into the boiling water, make sure the hole is facing down. When you lift it out of the boiling water, if the hole is facing down, the boiling water comes out the bottom, and then you put it into the calorimeter. Okay? You don't want to put a cup full of boiling water into your calorimeter because the water will change the temperature too, and you don't want that. Does that make sense to you? Okay, so that answers the question, how much water? Okay, go ahead.
Into the boiling water for 3 minutes, and then after that we also need to put the sink water, tap water into the styrofoam.
Into the calorimeter, yeah.
Calorimeter, same thing.
And then put
He goes to the styrofoam.
enough water to cover aluminum into styrofoam.
I use the styrofoam.
Calorimeter.
We'll need to record the initial temperature of the water in the calorimeter.
Yeah.
Wait. Yeah, because we're measuring the temperature of the water in the calorimeter. So we need to measure it beforehand and after we've put the aluminum in there.
Yeah.
So,
Well, aren't we finding the specific heat of aluminum? So we're getting the aluminum up to 100 degrees Celsius by putting it into the boiling water. And then we're putting it into the other water and seeing how high that gets to.
yes. So we're recording the temperature change of the water, not the aluminum. Yes.
But you also have to make sure you record the initial temperature. Because then, wouldn't you find the temperature with the change, like the difference it was,
Yes. I think.
depending on how much it changes or what it gives off, I guess.
Okay, what's the matter?
It's just I'm trying to understand like how to like find the temperature. So what I'm getting is we're getting the aluminum like up to like the same temperature as like boiling 100 degrees Celsius.
Right.
And the peaker. And then you're already going to have enough tap water in the calorimeter, and then you're going to put the boiling.
So you have the temperature of the calorimeter, right?
Yeah.
And then when you put the metal into the calorimeter, what temperature what'll happen to the temperature of the water?
It will go up.
Right, so you measure how high up it goes.
Yeah, and that would be that's what
Okay, so what's your starting temperature of the metal?
100 degrees Celsius.
And your final is what you're recording, right?
Yeah.
So the final for the metal is the same as the final for the water.
Okay.
Because the metal cools down as much as the water heats up, so they end up at the same temperature.
Okay.
Does that make sense?
Yeah.
Okay.
What kind of data table do we need?
Just anything that you said to measure, you need to record. Yes.
Okay, so are we putting the metal piece into the calorimeter with no water?
No, the calorimeter needs to have enough water to cover the metal.
So
That's where I said the amount is enough. So you're boiling amount of water, and that doesn't matter. It just has to be enough water to put the metal into. In the calorimeter, it's cold water out of the sink. And all you're doing is taking the hot metal and putting it into there and making sure it's covered.
okay, so we're boiling the water, putting the metal into the water until it's boiling.
Right, and that water stays over here in different water.
And then once the metal's boiling, then you put it into calorimeter with cold water.
Right, and then you measure the how much that temperature goes up, and all that heat
Okay.
that goes up is coming from the metal.
Gotcha.
Okay. Yes.
The aluminum in the water, do we have to wait for a certain amount of time before?
Wait for the temperature to... After you put it in the calorimeter water?
Yeah.
Wait for the temperature to stop changing. So it'll go up, and when it stops going up, that's the temperature you record at. Yes. Yes.
So do we get the temperature from at the start and then put in the water and then get it again after 3 minutes? Just completely.
So you have metal that you just put into boiling water.
Yeah.
You have a separate container of water with enough that is enough to cover the metal in the calorimeter. Okay. The boiling water never goes into the calorimeter. The cold water, you take the metal out of the cold water and take the metal out of the boiling water, put it in the cold water, measure the temperature.
So that's what number is that? Is that the
TF.
Is that the delta T or whatever?
It's TF.
Yeah.
T initial you took before you put the metal in. T final is how high it goes up.
So how do you find?
She orders a different drink every day.
Wait. Don't we need to find the specific heat of aluminum so we can calibrate it?
Right. So
how do you do that?
You have the mass. You'll have a delta T. You'll have Q because you're solving for water first.
What? We're solving? Oh.
There you go. Okay. All right, you guys have reached the point where you're trying to figure out what exactly it is you're trying to solve. And how many of you are confused? Frustrated? I wish the camera was following your hands. All right, so it's like everybody. So how many of you would like to just go through it one more time? Yes. Okay. So, to start out with, what is in your calorimeter to begin with?
Water.
Cold water. Okay? And you know the mass of the cold water.
Yes.
And you know the starting temperature of the cold water. Yes. Okay. And you know C for cold water. What is C for cold water? 4.186, the number I told you to memorize. So if you have these numbers all together, you can solve for Q. Okay? That'll be Q of the water. Okay? So you got your water all figured out. But then you're going to, just wait. Then you know that the heat that comes to heat the water up in the calorimeter, where did it come from? The aluminum that you put into it. So if the Q of the water, if the change in the water comes from the aluminum, then the Q of the water is negative Q of the aluminum. So you're going to have this same equation. You're solving it first for water to get Q. You plug that in for the aluminum, and you have Q for the aluminum. Okay? And then you have the mass of the aluminum because you have a scale. You don't know C. That's what you're solving for. So you solve for Q of the water first because you can figure all the rest of it out. and the delta T of the aluminum. Okay? So you have to go through 2 stages. The first stage is figure out what happened to the water so you can get Q. Once you have Q for the water, plug that Q in for the aluminum and figure out C for the aluminum. Okay? So the thing that I think most of you are getting stalled out on is this. You're taking the temperature of the water to figure out the temperature of the aluminum. Okay? This is what you need to know. The ending temperature of the water is the same as the ending temperature of the aluminum. They have the same Q final. So when the water heats up, that's the same temperature the aluminum ends up at.
Do we need to measure the temperature of the water at the beginning, or is that the number that we're supposed to?
The temperature of the water at the beginning is whatever's in your calorimeter. It's temperature.
Okay.
Okay.
And then you subtract final.
Yes. Okay. So how many of you have 5 procedures written down?
I have 3.
Okay. How many of you have a starting procedure that basically says put water in a calorimeter? Okay. And you said enough, right? You said take the temperature of the water? Did you say find the mass of the water? Okay. So you're doing that perfectly. Okay. And then do you have something that says boil water in a beaker? Okay. You don't need the starting temperature of the boiling water. What is the starting temperature of boiling water? 100 degrees. So that is your starting temperature of your metal. Okay. So then do you have something that says take the metal out of the boiling water and put it into the calorimeter? Does it say carefully? Does it say beakers or glass and you're using metal, don't drop the metal into the glass? Okay. Word for, I know, and it probably says exactly that, right? So you're putting the metal into the calorimeter, and then what do you need, what information do you need out of that? Change in temperature. Okay. So record the change in temperature. All you do there is you look, the thermometers are like the old glass thermometers, right? So you're going to have to lift it a little bit up and read the temperature of it and put it back because it'll be covered a little by the cardboard. But when you do that, you're just looking for the highest it gets. There'll come a point where it stops changing. That's where you have to stop recording. Okay? Once you've measured the change, in the temperature, then you're done. Okay? So then you take the aluminum out, put it back in the boiling water, carefully. I just did that. Don't do that. With the tongs, very carefully, and like keeping your eyes and the boiling water off your face and all that. You'll put it back into the boiling water and then refill the calorimeter and do a second trial. Okay, so just enough water, take the temperature. You can boil your unknown and your aluminum at the same time. You have to have them for a minimum of 3 minutes in the boiling water, but you can boil it until the water is gone. And until you do that, the temperature won't change. Okay? So you put them both in at the same time. So it's actually pretty quick, which is why we can spend all this time developing the procedures and then do the lab. Is you get the water in there, take the temperature of it, put the metal in it, take the temperature of it, pour it back out, do it again. Okay? That is all you're doing. You're looking for that little temperature change because it is the key to all of this. Because this is thermochemistry and all we care about is the therms. Okay? Do you understand what you're supposed to do now? Okay. Make sure your procedures talk, it's not time to move yet. Make sure your procedures talk about what it is, or everything that you need to measure, and make sure your data table has everything that you needed to measure recorded in it. Okay? Yes?
What is the Q stuff?
Heat.
Heat capacity.
Heat. Heat capacity is C. Q is just heat. It's in joules. Yes? Okay. What?
What do we need on the data table?
I felt written there. Anything that you measure, like the mass and all that, needs to be on the data table. Okay.
Ending temperature after the 3 minutes.
Water goes in calorimeter.
When I walk next to it, yes.
Do we have to find the mass of the aluminum?
Boiling water.
Yes. How do you find the mass of aluminum?
Scale.
Okay. And your unknown also. Okay.
You got a temperature. Then
So Ms. Paris, it's just the water mass,
Uh-huh.
Do we have two trials of the aluminum, or do we have a trial of the aluminum and a trial of the
two trials of each.
Okay.
Okay. Now this is the hardest part of the entire lab. I need one person from each group to raise your hand. And you all did. Okay. So ready? I'm going to predict your grades. Ready? A, F, A, F, A, F, A, F, A, F, A, F. Okay, there are two samples, two unknowns. There's unknown A and unknown F. Okay, so if I just assigned you your unknown, so you don't have to do both samples, just A or F. Okay. How many of you were super offended by that? I was super amused by that. The looks on your faces. Okay. Carson's like, I got an A. Okay, so here's the thing now. As soon as you're ready, you need to be wearing shoes. It is boiling water. You need to be safe, okay? Please don't cook yourselves. You need to be wearing goggles. And you need to make sure your materials list includes tongs, so you're not trying to take the metal out of the boiling water with your bare fingers. Okay? All right, you can head on over quietly when you're ready. Okay, goggles on, please. You're all going to need to add water to your hot plates. Get them going right away.
Wait, add water into here?
Yeah. Okay, I need just a second to get this stuff cleared up from last period. You guys here? Yes. Okay, you're going to need to grab beakers off the center table. All right. No groups of two. Everybody has to be in a group of three. So are you guys groups of two? Yeah. Okay.
What? President is we're running short on lab stations.
Like there's 36 students. That's crazy.
We're the graduated cylinders.
You're not using any. You use beakers. What?
Okay. You said 2 or 3.
Okay, you need to be in a group of 3 because we don't have space for this.
Well, we're already you just want us like combine.
Disperse, yeah. Just disperse.
Now.
Okay, no groups of 4, you guys. Okay, where's my other group of 2? Okay, thank you.
We're gonna have a group of 4 today.
No, we're not. There's mathematically that's not necessary.
We're a group of 2.
Okay. Here. Right here. Okay, get your water boiling, please. You guys need to add water to yours. Okay, goggles on, please.
There is. There's more.
All right. What?
Highlighter and foundation on their face today.
Oh, yeah.
Scale.
We have 12 lab stations and 36 students, so it can be done. I will as soon as people stop moving. I'm having the same problem you are, Ben.
I touched this with my fingers, right?
That was on camera. So you guys are a group of 3 here? Okay, and you guys are a group of 3? 3, 3. You guys are a group of 3 and 3, 3. You guys a group of 3. Who's working here? No one. Right here.
That's aluminum.
Okay.
Remember, the bowl has to be
Good. Put water into the beaker.
We already have
Yeah, you just need to add a little more. No, it's you have to turn it on. It doesn't work off. Oh, here. I took the reset button. These things don't. There you go. And you want it on high. Okay, so in the beaker you can put more water than that. Okay, because you're putting both of them in? Yes. Oh. No, turn it on as high as it goes. You just want it to boil. All right, so while you're doing this, you get your calorimeter ready and you get your metal ready.
Way minus.
We have to have that. Miss Paris, how do you read this thing?
Just fill it up so that it covers the aluminum.
We did.
You need it on here boiling. You don't. It doesn't matter how much is in it. You just need it to cover the metal and boil. So in your calorimeter, you need to put in enough water to cover the aluminum and then weigh the water. Make sure you don't get the weight of the styrofoam, just the water.
Okay, that makes sense.
Wait.
You're going to need more water in that.
This one?
74.
I don't want to pick it up. Is that?
That's fine.
So do we?
Now we're just waiting for it to boil, right?
Yep.
We need to measure the.
You have your calorimeter ready. That's probably more water than you need. You need mass of water, right?
Grams of water.
How do you clear it?
Okay, and that doesn't include the mass of the styrofoam, right?
No, we checked that.
You zeroed it out. Okay, great. What?
We did not zero it out.
But whatever you did.
We just subtracted.
So you zeroed it out,
Pretty much.
mathematically.
Yes.
How do you zero this out?
T.
115.
Is it not zeroing out right? It seems like the people in the last group had a problem with that one too. Let me see if I have another scale for you.
So we're gonna have to weigh the cold water also.
Is there cold water already in here?
I love
No, it looks like we're out of the balances. So would you guys mind sharing balances? Because theirs is not zeroing out.
It just did.
It did?
Yeah.
For real? Hey, good luck. If it stops working right again, just switch them out.
Did you tell you we're not supposed to wait?
Oh yes, that.
Alright, so
You are correct.
original temperature, looking at 20
Maybe that's just the temperature.
22 degrees.
We just put Celsius. Who wants to read it? Oh god. Okay.
All over your paper.
It was this one starting temp. Say
Yeah,
21.
starting, yeah. How much? 22 degrees Celsius. This is starting.
Can we get the scale back, please?
So now we
Well, we still need to find our mass of that. The mass. I
already got it. 32.55.
Oh, okay.
Yeah, we find the temperature of the cold water, right?
Yep. Yeah, you know the temp of the boiling water. It's actually not exactly 100 according to our thermometers, but we're not going to mess with that.
So this is stabilizing around 99.1. It says.
Yes. Uh-huh.
Are we supposed to put
You
that
can put
water?
them in before it boils.
You can?
Yeah.
Okay.
But slow down. The water's not even hot yet. I know, but you keep dropping it in the glass and I'm freaking out. Yes.
Okay, are we supposed to
That's
put
okay.
that water into here, or can I use?
This water is only for putting the metal in when you're done.
Okay.
This water never goes into that water.
Okay.
Okay? So this only has to be, do you have the mass of this water?
Yeah.
Okay. This only has to be enough water to cover the metal. That's all you need. Okay?
I don't feel like our gram should be 102, but I mean, what do I know?
Of water?
Yeah.
Probably about right.
Oh, really? Okay. I'm just
Most of them are between 95 and 105.
Temperature.
You got 89.
You need to get a thermometer.
That's not bad. That
You're right
means
there,
you're probably a
Ben.
little spatial reasoning is a little better.
I'm grabbing with my hand.
Okay,
Supposed
so
to put this in here while it's on the thing, or no?
yes, just very carefully set it in there.
It's not like staying on our tongue.
Oh my God, what are you doing? Just kidding. Go ahead. All right, you can put them both in at once. It just needs to boil for 3 minutes. Then remember, you pour it and do the next one. Okay. All right, you guys can put your metal in now. It's boiling enough.
Both of us, or they can?
All of you. Just put in all of your metals. Yeah, at the point where it's boiling, you probably want to use tongs. But I would do this. I would not do that. That was really, really bad.
You ruined everything.
I'm sorry for destroying your lives. Usually I'm a little more subtle than that. Okay, so you just take this when you're really close and then pick it up with the tongs and set it in instead of carrying it across the room. So that doesn't happen because that is just ridiculous. Okay, so sorry you guys. All right, so you guys, you're going to put your... Hey, when you guys are doing this, you can put your metals into the water now and then just after it's boiled for about 3 minutes, okay? But pick them up with your tongs when you're close, and when it's time to put the styrofoam into the metal into the styrofoam cup, put them close to each other. Don't haul it across the room, okay? And then when you guys, I'm not touching anything of yours ever again, but when you're putting the metal into the styrofoam cup, bring the styrofoam cup to the metal, okay? All right.
Are we supposed to have the metal in there?
Yeah, you can put the metal in now if you have its mass. You want its dry mass, right?
Oh, yeah.
Okay. And then when you have it boiling, or when it's done boiling and you're putting it into your, you should have water in this with a weight, right? When you do that, you're going to take the metal and put it into the styrofoam cup right next to it, so you're not like wasting a lot of heat as you're moving around. Okay, so get your water in there and get it starting temp.
I think it's
Yeah, that pretty much is it. And then you're going to end up calculating a Q, so you would add Q to that.
And then all these start at the 100.
Did you weigh it out?
The metal started at 100, right? Okay. The water temperature is whatever's in the calorimeter. Not 100. Okay.
But here's not boiling.
It'll start.
Really? That's funny. Okay, so when you guys are ready, when you guys are ready to put your now, I already spilled one of these once, and I'll do it to you too. No, it was totally accidental. When you're putting this is way more water than you need, and the problem is when you put the aluminum in it, it's going to overflow. Okay, so you're going to want to dump it and then remass it. Okay, but when you get your aluminum in, remember I said just enough. This is way more than enough.
Okay.
You get your aluminum, you bring your styrofoam cup right near it and put it in.
Is this enough?
Okay.
Just enough?
It should be between 95 and 105.
We're at 150.
Okay. So it's probably more than you needed, but it would be okay.
It'll be okay.
We were at like 100.
Yeah, you probably want 110, 115. But what I was saying was put the styrofoam cup near the metal and put it in. Don't have the styrofoam cup across the room. Okay. Wow. All right. When your wash pot finally boils, you can put the aluminum and stuff in right now if you want to.
It's starting to boil.
When it boils,
How do you take it out?
with the tongs.
Like through the hole or like?
No, you want the hole upside down so that you can lift it out.
Should we place it like this in there or like this?
Yeah, it's fine. You want the hole like aiming down as much as possible. Okay. And then when you go,
So it doesn't get. I see. That makes sense.
Okay. So when you're taking the metal out of the water, bring the styrofoam close to it and put the metal into the styrofoam. Don't have the foam over here and carry it across the room. You'll lose a lot of heat. So put it in now. Yeah, go ahead.
Okay, I think I'm gonna put you in charge of the tongs, Mason.
All right, you guys should be getting close. When it's time to put your metal into your water, just pull the tongs out. You'll lift it out, and you want it right here. You don't want to take the metal across the room because you'll lose a lot of heat. Does that make sense? Okay. You all right?
Yeah, I'm just really tired and my back is hurting really bad.
Oh, I'm sorry. And I made you move that desk. I'm sorry. Next time,
I didn't
just
move the
remind me.
desk, I just grabbed the stool.
Oh, okay. All right.
Also, we just measure the difference, not the metal.
How you guys doing?
Alrighty, Brent.
Do we need like?
I think this is meeting.
Okay, so it needs to boil for a couple minutes.
Yeah, and then you'll.
You're coming up in about 40 seconds.
Do we need like the temperature of just the water, like here?
At the end?
In the middle.
Well, the end temperature of the water is the same as the metal. So you need you take the temperature of the water, and that tells you what the metal is. Does that make sense?
Yeah. So do I even need like a column for this?
For start?
For just the water, because I have one for both metal.
You need to start the water. You definitely need to start.
Do aluminum first.
Okay.
That was just the temperature.
Alright. So it's going to start at 24, and it might go up to like 28, 29, and then that'll tell you what your delta T is. It's 5.
Oh, okay.
Okay. So is your aluminum in here? You need to be watching to make sure that the temperature, because the temperature will start dropping right away. So make sure. What was your start?
21.
And what is it now?
Like almost 25. 25?
Yeah. So it's gone up 4 degrees so far.
26.
But just when it stops going up. That's what you're right now. Okay. All right, you guys should be close.
Is that boiling?
What's your mass of water in there? Yeah, that's boiling. That's great.
Ours?
Yeah, what's your mass of water?
Walking us through it step by step.
You gotta dump it out.
You didn't take your mass of your water? I thought you did.
Are we?
No, that's your aluminum and your unknown. Okay, water, 117.28?
That wasn't that.
Okay, it's that water you need the mass of.
Oh,
Okay, all right. Yeah, because the mass of this is changing as it evaporates.
Yeah,
It's that you need.
That's what I was.
22.
How big is the change?
Small.
It's like 2
But
degrees.
Well, depending on how much water you have, between 2 and 8 degrees. Okay. So when you're doing the little one, you're going to want to use a lot less water, because the least water you use, the more precise it is. Okay. Just make sure it's totally covered, though.
Lady Macbeth.
Wait, you guys haven't read it?
Okay, so are you guys almost ready for the aluminum?
Almost. Because it wasn't quite boiling.
Yeah, this one has been really slow to boil things today. I'm sorry you got stuck.
We're gonna let's give it like another 30 seconds.
Okay, and then you'll put it in. As soon as you have this in, the temperature change that you're looking for, it's not huge, but you have to be checking all the time, because if it starts dropping again, that means you've lost some. Yeah, you missed your point. Okay, so you keep your eye on it, and then as soon as you have, or you can put your unknown in now. You should have your unknown in now.
Where is?
You were on the table. Okay. And then when you have your unknown, when you do your unknown, use a lot less water because it's smaller.
Miss Claire, so you're just supposed to wait till it's boiling, or do you wait 3 minutes?
3 minutes.
3 minutes past boiling. It's probably good now.
Okay.
But I want it to be as accurate. Okay, so then go ahead and do your aluminum.
Okay.
Okay? Make sure, remember, what did I say about the cup?
Put it near it.
Put it near it, okay? So you
Don't put it against it.
yeah, so you want to dump that water out the end of it. So lift it from that end. There, like that. That's perfect. Now when you lift it up, the water's going to spill out of it. Don't be freaked out.
There's water on top of it.
There, that's fine. That's not enough to matter. Okay, dump it in there. Now get the lid on and take the temperature, but don't stab it. Okay, the temperature only goes up by up to 10 degrees more.
Okay.
Probably less than that.
30 or 29.
All right, so don't be expecting a huge change. But as soon as you're done with this one, flip out the water into your unknown while your aluminum's boiling.
Okay.
Lexi, are you awake? I was thinking that. You okay? Are you healthy? You okay?
Very
What is wrong with this group? Everybody's
Dude,
sleepy.
I feel that. I have really bad.
You need help? Okay. Yes.
Yeah.
What's the question?
So the ending temp is the same temperature as the aluminum at the end, right?
Yes.
So the aluminum.
So you have TF for both of them now. There you go. Brilliant.
And then we do a second trial for the aluminum, or is the second trial the
You do a second trial of each one. So put the aluminum back in while you're doing your unknown, and then your aluminum will be ready when your unknown's done. Okay? So a total of 4. Okay? Okay, we got 10 minutes.
That was longer. Okay. We forgot to check how much water we needed for the unknown F while we put it for the boiling water, so we grabbed the extra with it.
Oh, that's brilliant. Okay, and so then just make sure you have the mask. I will stand here. Yes.
You have to tell you, I most likely won't be here tomorrow, but
You are so lucky.
I
Where are you
will
going to be?
still be here after school. I have
Okay.
an adoption at 9.
Oh, cool. Are you being adopted, or is your family?
Family member is.
Oh, that's so awesome. I'm glad you're going to that. That's really cool.
Thank you.
And then I will be
You
here tomorrow.
know my whole family.
Okay,
is adopted, so
let's
that's
what?
adopted, so that's really cool. Go ahead.
I will be here tomorrow after school to finish that test. For real, I will be here.
Didn't you tell me you'd be here last Friday? And I said no more chances.
But then, you did?
Yeah, and then
I was
you-
going to come last Friday, and then I had to leave school early. And I wasn't here.
Why'd you have to leave school early?
Because I went to prom.
So you chose prom over your commitment to me, just like everybody else on the planet does. I'm just so hurt.
I'm here every single day.
He's kidding. Just late like every other day, but.
I've never missed this class.
Sean, where
I am
are you?
so sorry.
Actually, that's not true because I.
Yeah, I remember there were like state days when you guys were gone.
Yeah.
It was so quiet. I mean,
It was so nice.
It was such a great class.
you guys had a great time. I, on the other hand, I was stuck thinking about it, and not able to go. It was so sad. So Megan, Friday.
Tomorrow after school.
Yeah.
Sure.
So that's for...
I feel like an old man.
How's it going?
I still think I did the
it's going really great.
but it's okay.
So what the problem that you're going to have is that you have water in every trial, and you only have one column for water.
Yeah.
So
Okay, I'll just one second trial right here.
how about put your other stuff down here?
What other stuff?
You have to do 2 trials for aluminum and 2 trials for the unknown.
This is I had trial 1 and trial 2.
Okay. You're just going to need trial 1 and trial 2 for the water, so put your other water down here for the unknown. Does that make sense?
Water 2.
There you go.
25.78.
Can I take the, finish my lab test today after school?
Yes.
And then can I also take the strong acid and base quiz?
Yes, that takes like 30 seconds. So, yeah.
Miss Paris, how many times are we supposed to do it?
2 trials for each type. Carson, it's quite all right.
It's okay. I when I pulled this one out of there, I dropped it.
What are you doing now?
I'm measuring the water. So that
Why do you have both of them in there? You do one at a time.
Oh my god.
Are you guys happy? Is that like the right place for this first one?
That's your mass, that's your C, and that's your delta T. That's perfect. Okay, so go ahead and solve for Q, and then that, whatever that number is, flip the sign of it, and that'll be your Q for your aluminum.
When's the test for this?
It'll be like next Wednesday.
I swear. It's on the 12th. I'm gonna cry.
Please don't
That's
cry.
next Wednesday. Is it really? Yeah.
Yeah, because Thursday we do a lab for the seniors because it's their last day.
I got it.
These equations for both trials?
Yep.
You're not gonna be here. I have 4 tests that day.
It's not a bad
Wait, when did you say the final was next Wednesday?
the test over this. I don't think the seniors are going to be taking a final.
That's smart. So I don't have to give the test either.
Right.
Yeah,
You
you'll
won't
be
even
gone.
be here. So it's Wednesday. You'll be like on an airplane.
In Washington D.C.
Oh, that's awesome. You'll love Washington D.C.
You want
Yes.
as least water as possible for unknown, right?
Yes. So just a little, just because it's a little more accurate. Okay, 6 minutes. Cleanup for this lab is turning off the the hot plate. You don't have to clean up anything else.
What are we at? 39.
No more disasters? Everything working okay?
As long as you don't touch the top.
I know, I'm not coming anywhere near you people. How's it going over here?
We're just getting our second final temperature for the young.
You have time to do another one?
All right, and then you have one more of aluminum when you're done?
Yeah.
No.
All right, you don't have to keep it boiling for 3 minutes after that first time. You can just, it'll be hot enough when you're done.
Well, yeah, this is our second one. We've already done one of aluminum. This is our first step of unknown.
Okay. I'm just saying you can, like, when you put the unknown back in, you can just immediately pull the aluminum back out.
Okay.
So you don't have to wait for 3 minutes.
Take out your.
Well, we added more water.
Okay, so you're on your first unknown trial?
We're on our second unknown trial, but we still have to do our known again.
Do you want us to do?
So you did your first
twice?
aluminum? Yeah, both of them twice.
Yeah.
2 trials for
Do you guys get it now?
Yeah.
Yeah.
We did our first trial wrong.
But you understand what you should
Yeah.
do? Okay.
Because I thought that you meant that we put both of them in the cup and do the water
Oh.
for the cup. So
I see.
I add water.
Science, this is Christy. Hey, Michelle. Yes, she is. Oh, will do. Thank you. Bye. Okay, 5 minutes. Just 1 second. Meredith, your phone is in the main office after class. They just called.
My mom probably dropped it off.
That was nice of her. Just a second, I have to answer this question. Yes.
Oh, I was just gonna say, do you have a value for the aluminum per grams, or should we just wait? Just make sure.
You should weigh it.
Because we forgot to wait before we boiled it.
I would take it out when you're done with your trial, dry it off, and take it. Did you have a question?
Oh, yeah, sorry. So
That's a beautiful, perfect.
Oh, okay.
Yeah, you guys are doing great. Thank you.
Yeah, I know.
We're waiting on a thermometer.
Yeah.
Oh, are you sharing a thermometer?
Yeah. There was another thermometer.
For the starting
Fancy one.
Those are easier to break. Be careful.
Wait, did we need it way because it was hard in 8th grade?
Should I take it out? Yeah. That's the M part that you were solving for. They're not hot anymore if you put them in the cold water. You don't have to use tongs.
Second trial.
Yes. However, we're going to start class tomorrow with the second trial.
Okay.
So when you guys are done with this trial, just turn the water off. Okay? And then take the metals out of the water and set it on the water. Okay, when you guys are done with this trial, turn your water off, make sure the metals are out of water, and we'll finish everything tomorrow. Okay? Okay.
6:36.
When you guys are done with this trial, turn the heat off, make sure the metals are out of the water, and then we'll finish the last trials tomorrow. Okay? You guys got all your trials done? Okay. Did you guys get all your trials?
I think this is the
Okay,
end
great.
of it, yeah.
So just make sure you don't leave any metals in the water and turn off your hot plate. Okay? Do you guys finish all your trials?
We are just doing our last one.
Okay. So what I need you to do for cleanup is turn your hot plates off and make sure you don't have any metals in water. Okay. Thank you.
We have the weight of the cup zeroed on it on the scale.
No, we need to take it out just for like take it out.
What are you trying to do?
We need to get the weight of the metal.
So take it out of the water, dry it, and weigh it.
Or you could just.
Well, we can just do it tomorrow, Bill.
We don't have time.
You don't know for sure. You have just take it out. Are you done with your?
We're done with our trial right now. Yeah.
Yeah. So just take it out of the water, dry it, and weigh it.
What's that, kids?
Okay.
Taking it out of the water, the real
It's
challenge.
cold. You can just reach in there.
Is it?
It's cold water. It's not gonna.
It's like 28 degrees.
Do you want us to leave our medals? Our
What?
medals here?
Yeah, you can just leave everything there. I'll clean it up.
Okay.
We're gonna finish the trials tomorrow, so we'll just leave it set up.
Well, I didn't know if you wanted us to have the same medals as we had, if that affected it.
Well, you'll have to start by taking the mass tomorrow.
Okay.
Okay?
Yep.
Okay, the bell's about to ring. We'll do the follow-up questions tomorrow, okay?
Oh.